This week we're going to slow it down a little bit, give you a chance to catch your breath, maybe look over some older items if you need to, and just take care of a couple of items that are important to know about. And those are the idea of overloading methods and the keyword in Java, actually in many programming languages, called this. So let's start with this example. Suppose you're ordering food at a restaurant, a Chinese restaurant, and you see the menu on the right. Now, how might you go about actually placing your order? You might say, I'll order a number 104. You might say, I'll order a Hunan beef. Or maybe I'll order a number 110 with lo mein. Or I'll order an orange chicken with fried rice. You get the idea. Now, the important point is that in all four of these cases, you're doing essentially the same thing. If we were to program it, we'd probably call it something like place order as our method. The difference is in how we're placing the order. Specifically, what information, what data are we providing this place order method? Now, how do we solve this in programming? Well, I suppose we could have four different methods with four different names, like place order by number, place order by name, place order by number and side dish, etc. But you can see how that would quickly spiral out of control. So instead what we do is we just write one method called place order. And we can call the method place order by passing in an int to represent the menu number. Or we could have a different parameter, place order with a string instead, the item name. Or place order with two parameters, the menu number and the side dish. Or place order with the item name and the side dish name. And these four examples all match the ones on the previous slide. Now, will Java be able to figure out what we're talking about in each case? Well, think about that for a second. Even though the method's called the same thing in each case, the list of parameters is different each time. This is what we call overloading a method. Now, before we continue, there is one thing that you could not also have given the four that we have previously. I'm going to show it to you. You might want to pause just for a moment to think about it, and then I'll come back and explain what the problem would be with this. Okay, so perhaps you thought about that. Why couldn't you have int menu number string customer name? That's different than any of these for sure. And it certainly makes sense that you might want to capture the name of the customer, etc. Well, you have to remember that these variable names, menu number, item name, etc., we write those as a way to capture the data. But in the class that calls the method, the one that calls place order, remember, it's only passing in the data. For example, here, it might pass in place order 104, comma, lo mein. The problem is, how would Java know whether the int it gets, the int's 104, but how would it know whether the string that follows represents a side dish or represents a customer name? Maybe my name is lo mein, or maybe there's a side dish called Charlie. I don't know. The point is, what you can't have is the same type of data in the same order for your parameter list. So if you already have an int followed by a string, you've got to come up with some other way to deal with an int followed by a string. So here's the idea of overloading methods. Overloaded methods have the same name. They have different parameters. Again, no two can have the same types in the same order. Now, the return type of the method may be the same or different. That really doesn't matter. So I've written three examples here for you to look at. Here's the first one, public void place order int menu number. So in this case, you'd pass in the number from the menu. It would do something to place the order, would not return any value. Maybe in the second version, we pass in the menu number, but we also pass in a quantity as an example. Now, is that okay? This one had an int. This one also has an int. Yes, this is okay because this has an int followed by another int. And that's different than having a single int. Finally, maybe we have a place order that returns a Boolean. We pass in the item we want to order. We pass in the time needed. And maybe what this returns is true or false, whether the dish can be prepared in the amount of time requested. So notice they all have the same name, they just have different parameters, and they will behave differently based on what gets passed in. Now, whether you've thought about it or not, you've already dealt with overloaded methods in this class. Specifically, whenever you call that print line method, if you look at the the documentation of print line, if you think about it, print line can print a char if you pass a char to it. It can print a double if you pass a double. It can print a string if you pass a string. So I'd like you to try this out. There is an exercise called Overloading Methods on your worksheet. Has to do with a room and a room runner class. And as we've done in previous weeks, why don't you give that a try? Pause the video. And then when you think you're ready to take a look, come on back and I'll show you what it should look like. Okay, so our first exercise is to write an overloaded constructor where the calling class passes in values for each instance variable. Let's take a look at that in Eclipse. So the current constructor simply sets the values, length, width, height, etc. So we're going to write an overloaded constructor. So in any case, I think what we could do is we could pretty much copy this constructor as is, paste it down here, and the difference is that rather than just set these values, we're going to take in some parameters. We're going to say string, maybe color, comma, double, len, and again, for now, we want to avoid using the exact same variable name as the field is called. So if the field's called length, maybe we'll call it len. If the field's called width, we'll call it wid. Because these variables here are specific to this method. Okay? They're not these variables up here. So just to keep that all straight, it's probably easier to do that for now. Okay, and what do we have left? Height, double, and again, we'll just go maybe HT, and then comma, string, DESC. And the only change now is that the wall color is not going to get set to white. It's going to get set to whatever is in the variable color. Notice how when I highlight color, it also highlights here to show us that this variable is the variable getting passed in. Whereas wall color, if I highlight that, is the field up here. Okay, we'll do the same thing for each of these. Length will be len, width will be wid, height will be HT, and finally description will be DESC. Notice two versions of the constructor, one with no parameters, one with parameters. Okay, next it says in Room Runner, create a new room using this other constructor. Okay, let's try it then. So we'll go back to the Room Runner class. And why don't we make a room called, I'll just say bedroom. So we'll say new room, parentheses. And now we need to match the arguments to the parameters. So we need a color, a length, a width, a height, and a description. Now technically from this perspective, we really need a string, a double, a double, a double, and a string. Okay, so in any case, let's make this one purple, 9, 12.5, 8, and in quotes, bedroom. And just to test it, why don't we do bedroom.getWallColor, print that out, and make sure that in fact we get purple as the answer. And if we run it, you see the very first line does say purple. So we're going to assume that the rest of the fields got set correctly. I just don't have any getter methods to access those right now. All right, back to the exercise. In Room, create one more overloaded constructor where the user passes in the length and width only, and the other values are automatically set to 8, white, and generic room. So as we can see, it's perfectly acceptable to have several different versions of a method as long as all the parameter lists are different from one another. So we're going to pass in a double for, I believe it was length and width, it said. So double for length, double for width. Even though these are both doubles, recall you still have to repeat the type. Double, comma, double. Okay. Now what will this one do? Well, once again, we can pretty much just copy this in. Actually, it'd be quicker to copy this one in because it's more similar. And the only change is that length is going to get set to what they pass in. Width is going to get set to what they pass in. But the rest of it, the white, the 8, and the generic room will stay as in the no args constructor. You can see here I have an extra comma. Let me just get rid of that. There we go. Okay. And let's go back to the exercise. Again, try out the method by calling it appropriately from the Room Runner class. Okay, so back to Room Runner, and we'll cheat a little bit. We'll just copy this one, and I'll put it down there, and I'll just say, I don't know, what do we call this one? Bathroom. Now, all I'm passing in is, let's see, 2 doubles, the width and the length. So, I don't know, 12, comma, 15. And again, I'm going to copy this and paste it just to make sure that it seems to work. Again, it would be better to have more getter methods so I could actually find out all the values. But the wall color should be, what should it be? Well, in this constructor, it sets the wall color automatically to white. Okay, so let's try it. And you can see the first room is purple and the second room is white. All right, back to the exercise. Overload the set wall color method with a method that takes no parameters and just sets the wall color to white. Okay. So we currently have a set wall color method where you pass in a string and it sets the wall color to that color. Well, we could have a different version of that. I'm actually going to put the other one first. It's just more common to have the simpler version, if you will, come first. So set wall color will simply set the wall color to white. And again, notice there's no problem with having the same method name as long as there's a different set of parentheses. So let's try that in the Room Runner class. We'll go back, and why don't we go back to our bedroom, which, if you recall, is a purple room initially. Notice how Eclipse is now giving us 2 choices. Which version of the method do we want to use? Okay, it's always sort of a cool feeling that Eclipse actually recognizes that you've created these methods. In any case, I'm going to choose this first one. Okay. Now, when I print out the wall color of that first bedroom, it should have been set back to white. So now both rooms should be white. Let's try it, and we get white, and we get white again. Last exercise. Overload the find area method so that the calling class passes in an int representing the number of coats of paint. The method should not return anything. Rather, it should print out the total area of paint. Now that would be the area of the room times the number of coats. Okay, so back here, back to room. We already have a find area. And again, I'm just going to go ahead and copy that just to save a little bit of time. Now this time it says it doesn't return anything. So as I mentioned, overloaded methods can have different return types. But this time we're going to pass in a number of coats. And this time the area is going to be the length times the width times the number of coats. And it said it just needs to display that result. So SYSO, control space to save some time. And I'll say the total area is, and the quotes, notice with the space in there to have it look nice, plus area. Okay. Oops, missed the quotes at the beginning. There we go. The total area is plus area. And let's try that on one of our rooms. So it doesn't really matter which room. Why don't we say the very first room? My room dot find area, and this time we're going to do with the number of coats. So let's say we want to have 3 coats of paint. Okay, and let's go ahead and run this and see what we get. The very first thing we get is the total area is 1500.0. By the way, you might be wondering, how come I didn't have to have a print statement around this? How come I could just run the method and I ended up getting something to print out? That's because in the method itself there's a print statement. And you can decide as a programmer whether you want a method to return a value, which you then print in the calling class, or whether you just want to call a method and within the method it prints the result. It's just a choice that you can make, but I wanted to make sure you understood that. So that is how you overload methods. So I have written a simple class here. It's called Circle, and all it does is describe a circle. I just chose one instance variable, which is a private double for the radius. Remember, private means that this value can only be directly accessed from within the circle class. If some other class wants to get the radius, it would need to go through a method, in this case the getRadius method, to find out that information, or for that matter to set the information. And I have 2 constructors, one with no parameters, no args, no arguments, and it just sets the radius to 10. The other one where you pass in a double, and it sets the radius to that double. And we have, as would be expected, a getRadius, a setRadius, and finally we have a compute area that figures out the area of the circle and returns it. Now, let's take a look carefully at this setRadius method. We've seen methods like this quite a bit now. Notice how it works. It's void, meaning it doesn't return anything. It's public, meaning it can be seen from other classes. It can be used by other classes. Now, let's recall what it means inside the parentheses. Double R means for this method to do its job, you need to give it a double value. What this R means is simply the local variable name that this method uses to capture that value. So the only place that this R can be seen is within the setRadius method, and its only role is to capture the value passed to it. I have here a circle test class, and here's an example. When we have circle1.setRadius20, the 20 gets passed, it gets captured here and put into this variable called R. Now, I've made a big deal about calling this variable something other than radius, even though ultimately what you're really doing is passing in a value that you want to get into the radius. The reason that we don't call it radius, or have it up to this point, is because if we call this radius, this is a local variable for this particular method. It does not refer to the radius that's actually the field. And you can tell, see how radius just lit up here? To indicate that this radius that we want to set is actually not the field. It's now become this local radius. So that's not going to work. Okay? What we'd love to be able to do is say something like radius equals radius and make Java understand that what we mean is that we want to set the radius field, this guy right here. That's what we mean by this radius, and we want to set it equal to the radius that was passed in. And the way that that is done is by using a keyword called this. If we precede the first one by saying this dot radius. Notice what happens. Now, as you can see, it does refer to the field. So what does the this keyword mean? When this precedes a variable name, it means you're referring to the field, the instance variable. And you can think of it this way. It's meaning the radius of this circle, the circle that's currently being used. So for example, if I go circle1.setRadius, this circle would be circle 1. So this radius, i.e. the radius of circle 1, should be set equal to the variable radius. So important to understand that over here, these two radiuses, radii, whatever, are the same variable. This one is the actual field. Now, this is a hard topic for a lot of people, and honestly, you can get around it by simply not calling this radius, but I did want to show it to you because you see it a lot in code, and if you get it, it is a very convenient way to write code. So I'm not going to require you to use it, but I just wanted you to see it. And while we're on the topic, incidentally, anytime you refer to an instance variable, you can always precede it with the keyword this. Okay? That means exactly the same thing as what was there before. This dot radius equals 10. You don't need the this keyword here because there's no other radius variable to confuse it with. But my point is you could do it. In this other constructor, you might again want to say, no, what I'm passing in is the radius. And now I can write this dot radius equals radius. If we look at this method, get radius, return radius, again, we could say this dot radius, but I'm not going to because there's no other radius variable in this method to confuse with the variable radius. Okay? Now, one advantage of using the this keyword is in this calling class, suppose I say circle2.setRadius. I don't know if you can read it, but in the Eclipse help tip here, it says set radius double radius. So it actually uses the correct name. So that's kind of a convenience. And of course, that's just an Eclipse thing, but it does help somebody, when you're writing the program, it does help you understand how that method works. Okay, so I'll just say 7.